Hello everyone. So today we are learning transformation using matrices. So we have learned basic transformation at school, and we have also learned a basic matrices operation in the previous video. So today we are just combining these two together. Yep. So previously we understand identity matrix has a form of 1 0 0 1, and we are sort of using this idea today. Yeah, and at school we learn about reflection in the x-axis, and that means that let's say we have a point and we have an x-axis right here. So a reflection in the x-axis will sort of like be reflected downwards, yeah, or from the downwards upwards, yeah. So this means that my x value does not change. However, the sign of my y value is actually changed, yeah. So if we look at the rule, yeah, x prime is the image of x will be equal to 1x because it doesn't change, plus 0y. We don't consider the value of y in our image x, yeah, and y prime equals to 0x negative 1y. The reason why we put a negative is because it's being reflected, yeah. So if we convert this into a matrix, it's going to give us 1 0 0 negative 1. So 1 0 0 negative 1, it's pretty similar with the identity matrix. It's just that right here for the second row, second column right here, it's a negative 1. That's because it's a reflection in the x-axis, and we have to remember that, yeah. So this means that for the reflection in the x-axis, the y value becomes negative 1. Yeah, we can also see that for the first column here, it's actually the x value. So these are the x values. Yeah, and for the second column here, this is the y value. So we are actually changing the y value over here. So if this is a reflection in the x-axis and we put a negative 1 for the y value, yeah, if we see a reflection on the y-axis, of course we have to put negative 1 where there is an x value. So again, if there's a coordinate and this is the y-axis, okay, a reflection in the y-axis gives us a value that's right here, here, yeah. So we are changing the signs for the x, yeah. So if there is a dilation of factor k from the y-axis, yeah. So do you still remember me mentioning that a dilation is sort of like a single way stretch? So if we have a y-axis and we have a point here, we are stretching it like sort of this way. So it's sort of like the x values that has been changed but not the y. So we have to times the x value with the dilation factor and not change the y value, and therefore it's going to give us like sort of a matrix that's K001, pretty similar still to the identity matrix. It's just that if it is a factor k from the y-axis, we put this k into where the x is. So we are actually changing the value of the x, yep, not the y. So dilation of factor k from the x-axis, we will put k at where the y is. So it's going to give us 1 0 0 k. A reflection in the line y equals x, yep, as we have discussed this previously, your x and your y value swaps when it's reflected in the line y equals x. If you are confused up to this point, I encourage you to draw this on your Cartesian plane, and you will see it and you'll further understand it. Okay, all you have to do is press pause and sort of draw it in the Cartesian plane on a piece of paper. Yeah, so the image of x will be equal to the y of my object, and the image of y will equal to the x of my object. So it just means that the x and y actually swap value, yeah, and because of that our matrix is 0 1 1 0. And as for translation, we know that translation, we are either moving it like sort of vertically or horizontally. And so for the image of x, we put here x plus a, and image of y is y plus b. The positive a is when it is moved like a steps in the positive direction of x. Yeah, so I will put plus a. If it is sort of in the negative direction, you have to change this to negative. Your a has a negative value. Yeah, and so is the for y. Yep, it's the same. And if we go to a question, yep, this is actually from the table, yep, that we have learned just now. For the reflection in the y-axis, we know that we have to put negative in front of the x, and therefore that's the sort of like the corresponding matrix for that, yeah. So if we have a question, find the image of 1, 4 under a reflection in the y-axis. So this is a point, yeah. So how do we do it using matrices, yeah? So we have to put the transformation matrix right in front, and we have to convert this coordinate into a 2 by 1 matrix where the x is the first on the first row and the y is on the second row. If we do this, if we times this together, this will give us a new matrix which is negative 1 and 4. So this means that 1, 4, the original point, maps onto the image which is negative 1 and 4. So this is how what happens when one point is reflected in the y-axis. Yeah. So let's say we are doing the next question. Yeah. Find the image of the same point under a dilation of factor 3 from the x-axis, and as we have learned previously, if it is a factor 3 from the x-axis, we are changing the y, sort of like the y value. So it's previously, this is what we have gotten from the table just now. So this is going to be 1003. Yeah, so 1003 is the transformation matrix. We have to put it in front. Yeah, and the point converted to matrix, we have to put it at the back, and timesing them together gives us 1 and 12. Yeah, so this means that the point of 1, 4 maps onto 1, 12 under a dilation of factor 3 from the x-axis. So if we have another question, okay, consider a linear transformation such that 1, 0 maps onto 3, negative 1, and 0, 1 maps onto negative 4, negative 2 and 4. Find the image of negative 3 and 5 under the same transformation. Yep, I think I must have forgotten to type that down, but under the same transformation. Yep, we don't know the transformation matrix in this case, but we sort of have like two clues. Yep, we have one object mapping onto its image and another object mapping onto another image under the same transformation. So in this case, we can sort of like create a transformation matrix and put pronumerals inside them first, because we have to solve it, yep, to sort of find out the transformation matrix. So if we assign A, B, C, D as a transformation matrix, and the first point is actually 1 and 0, timesing these two together will give us sort of like a result of like AC, which is the image of the object, which is 3 and negative 1. So by doing this, okay, that's my cuckoo clock. Yeah, we'll just ignore this and we'll carry on. So A will give us a value of 3 and C will give us a value of negative 1. Yeah. So this is the first clue, and we can find the value of A and C already. Yep. And by using the second clue and the same matrix, because it's the same transformation matrix. Yep. So it's the same transformation, and if we put 0 and 1 down and timesing this together, it gives us B and D, which has an image of negative 2 and 4. So this means that B has a value of negative 2 and D has a value of 4. Yeah. So putting this together, we can actually have the transformation matrix already. And now we have to find the image of negative 3 and 5 under this transformation. Yeah. So as usual, the image of x and the image of y will be, the transformation matrix has to be first, and then we will put the sort of like the coordinate of the object right here, times them together, and therefore we get sort of the image of x and y, which is negative 19 and 23. So now we know that negative 3, 5 maps onto negative 19, and 23 under a particular transformation. So if we have a composition of mappings, that means that there are actually two transformations. Okay, so what must we do about that? Yeah. So given a question, find the image of the point 2, negative 3 under a reflection in the x-axis followed by a dilation of factor k from the y-axis. So this means that we have to do the reflection in the x-axis first, and then we have to do the dilation of factor k from the y-axis. So as we know previously, a reflection in the x-axis have a sort of like an identity matrix 1 0 0 1, but we have to put a negative sign where the y is. Yeah, and a dilation of factor k from the y-axis, you have to times the k to your x, and therefore you get k001. But we always have to remember for a composition of mapping, so let's say that there's two transformation, and the reflection goes first. It has to be placed here. It has to be placed on the right side, and the one that goes last have to be put sort of placed in front of it. Yeah, so this is an important note because yeah, there's a lot of people making careless mistakes out of this. So yeah, whatever that happens last have to be first when you are putting it in, arranging it in a matrix equation. Yeah. So timesing these two together gives us a value of k0, negative 1. And after we have sort of the transformation matrix, we can actually find the image of this point, yep, by finding the product of it. So this will give us 2k and 3. Yep. So I'll just quickly go on to the next question. So find the image of xy under a dilation of factor k from the y-axis, followed by a translation defined by c. Then we have to find x and y in terms of x prime and y prime. So it in terms of their sort of their image. Yeah. So in this case, we know that we have to dilate first and we translate. But translation works differently from the rest of them. If you realize previously, all the other matrices are all 2 by 2, but translation is sort of like a 2 by 1 matrix. So it's sort of it works differently. Yeah, so we know that the matrix for a dilation of factor k from the y-axis, we are actually timesing the k to the x, so it's going to be k001. So we don't know the value of our image, so it's just going to be xy, and our object, which is going to be xy, and our image is just going to be x prime and y prime. Yeah, so if we need to do a composition of mapping here, we cannot do, because just now I mentioned that if we are doing this sort of last, you're sort of doing it first, but that doesn't happen for translation. We have to dilate first. So the transformation matrix is in front, yeah, and the object is right here. So we have to dilate this first, and then we will follow it by a translation matrix. So we have to add the translation, and this will give us a sort of the image of the point. Yeah. So in order to find, because the question here is find x and y in terms of x prime and y prime, we sort of need to make x and y the subject. Yep. So we have to sort of single out the x here. So what we're doing here is we're sort of moving the c across the equal sign. So if we move this across the equal sign, it's going to give us a negative c. Yep. And if we move this across the equal sign, we have to times this. We have to times the inverse of negative, the inverse of matrix A. Yep, in front of the both sides of the equal sign. So this is gonna give us this. Yep. So if we actually have a matrix A and we inverse it, it will give us an inverse of matrix A as 1 over k001. And if we sub this into this equation over here, we are sort of gonna get